In short, today we will see fast, but the previous two, the first one and second one is very important. The first is precipitation reactions, agglutination reaction, complement fixation test, neutralization test, immobilization test, immuno-fluorescence test, radioimmunoassay. In short, it is called as RIA, and enzyme immunoassay, that is ELISA. So these are the different antigen antibody reaction test. At least you should know the names of reactions. There are some other reactions also. So out of that, we will see detail about the previous two reactions, that is precipitation reaction and agglutination reaction. So this is the precipitation reaction. What is the principle of this reaction? That is also called as definition of precipitation reaction. Precipitation, you know, in the chemistry, you have studied in 12th and school also. What is the precipitation reaction? That is when soluble antigen combines with its antibody in presence of electrolyte, that is sodium chloride, at suitable temperature and pH, the antigen antibody complex form as insoluble precipitate. That is the definition of precipitation reaction. So the definition of agglutination reaction is also same. Only one difference in definition of these two reactions, that one term you should take into consideration, that is the physical nature of antigen. Here it is in precipitation reaction, the physical nature of antigen is soluble. While in agglutination, we will see later on that in the physical nature of antigen is insoluble, or it is also called as particulate antigen. So the definition, this question can be asked in theory also. Detail about each test, so you should know the principle of definition, that is insoluble antigen combines with its antibody in presence of sodium chloride, proper temperature and proper pH. Precipitation formation is there, that is called precipitation reaction. There is one flocculation reaction, we can call modification or some difference in this flocculation. Instead of the floccles, instead of the precipitation, the floccles suspended at the top of the solution, that is called flocculation reaction. So example of flocculation reaction, you should remember, that is VDRL test. In syphilis topic, uh, the VDRL test is studied in detail. So that is example of this flocculation test, or basically that is precipitation test. Then there is one type of phenomena, that is called a zone phenomena, when we combine the antigen and antibody, or mixing of these two is done. What happens uh, at only the middle part, or in the secondary step, we can see the zone of equivalence phenomena, means the number of antigen combines with antibody, that is in equal proportion. In that zone, or in that case, we can see only the precipitate formation. Otherwise, in case of some antibodies may be excess, that is called as frozen phenomena. In some cases, antigen is excess, that is called as post-zone phenomena. So this zone phenomena we can see by this diagram proper way, you can understand. See here, we have seen in the last lecture that structure of antibody, that is Y-separate antibody is there. Here is binding site of, and here you can properly see binding site of antigen is there. There are four antibodies here, you can see. So see the, in this case antibody is in excess. These are antigen. This one. So antibody is excess. So in this we cannot see the proper. Our reading is not taken. So antibody is excess. Here antigen is excess. See, these are the antigens, blue color. So antigen is excess here, and these are the antibody. So in this also we cannot see precipitate formation. But see here in this middle picture we can see the antigen as well as antibody. Number of these equivalence is there. Appropriate, no antigen excess, no antibody excess. So we can see properly the precipitation formation like this. Here you can see no precipitation if antibody is excess. Here also if antigen is excess, no precipitate formation. But only in the middle part like this, when the antigen and antibody is in proper proportional, in that only we can see the precipitate formation. So this is called as zone phenomenon or frozen phenomenon. These are the various uses of precipitation reaction or application of precipitation reaction. The precipitation reaction is very important or sensitive for detection of antigen. So see here, 1 microgram of protein or antigen can be detected by this precipitation formation. So these are very sensitive for detection of antigen or the foreign particle. So these are the forensic application. Forensic application. First one is identification of blood and seminal stain. In the cases of murder or rape, you can see a small amount of stain, blood or seminal on the cloth we can detect by the precipitation reaction. That blood and some seminal stain is a foreign protein, so that is detected by if that is in very small amount, that is 1 microprotein that is detected by this test. Second use of this is testing of adulteration or food adulteration by mixing of the food. These are the application of precipitation reaction. These are the different type of precipitation reaction. So precipitate can be formed by different types. Rain precipitation, light flocculation, tube flocculation, immunodiffusion, electroimmunodiffusion. So these are the different types. So basically you can understand ring precipitate formation, this flocculation, then on the slide and detail in fast we can see first one by one. Ring test, see this picture. There is, see here, antibodies are there and antigen is there. If they are mixed, so this zone of equivalence formation is there at the center of the precipitate formation is there. So that can be seen like this. Example, we use the absolute concentration test for detection of precipitation. This is the slide population rate. Slide population rate. On the slide, here intestine arterial test. This is slide population rate. This is the population test. Example is one test for iron syphilis. Population for slide population. This is immunodiffusion. jail. See here precipitation in the jail. These are the different types. It is not important for you, but just single diffusion in one dimension. So this is the precipitation test done in jail. Double diffusion, double diffusion in two dimension, electroimmunophoresis, counterimmunoelectrophoresis, and rocket immunofluorescence. Very important. Let me just see. For example, of immunodiffusion is precipitation reaction occur in the jail. This is same picture. This is the immunodiffusion in two dimension that is done on the slide. This is agar, our jail on the slide. This is in the this. So there is formation of the this precipitate in the jail. Antisera is incorporated in the gel and poured on the flat surface. And these wells are cut. These are the wells. These are the wells cut and antigen is added. So these antigen diffuse towards the antibody which is present in the gel. This is the immunodiffusion. The gel that is radial. Direction is radial. That's why it is called as immunodiffusion gel. This picture is in the book. I think better we understand. Just now we have seen this is a slide. These are the wells in which antigen is added. Hmm. This is then on the disk antibody in the agar. So formation of the precipitin lines are formed here. These are like this reaction, same reaction between antigen and antibody by the formation of precipitation in line. This picture again given in book. First, it is called as immunoelectrophoresis. First, the antigen is separated. Here, the all components are separated. First, we should see from this side. Rough means cut is done there, and this is well. Agar is incorporated in the well and antibodies. So, this formation of precipitin is like this. These are stains. So advantage of this is we can keep the slide after staining like this. These are the lines of precipitation formation. Electroimmunodiffusion. This antigen antibody reaction is speeded up by electric current. This is the counterimmunoelectrophoresis. This involves stimulation of electrophoresis between the antigen antibody reaction that is also done in the jail. Clinical application is for detection of antigen like alpha-fetoprotein from the fetus, cryptococcus and meningococcus infection in the CSF. So that's CIEP. In short, it is called as counter-immunoelectrophoresis CIEP. That is detection of antigen from the CSF in case of cryptococcus and meningococcal infections. This picture antigen here, antibody here. So line of precipitation like this. This is same slide. A line of antigen and antibody is there. This is rocket electroimmunophoresis. The formation of line of precipitations are like this rocket. That's why this is called as rocket electrophoresis. Same. This is antibody mixed with the tail, and that is go down the slide. These are the wells, but antigen is added, and that is reaction is done. So these are the lines forms in the jail, and this is same slide. So Till now, we have seen the first reaction from the antigen and antibody, that is precipitation reaction. Very important for diagnosis or detection of antigen from the forensic application. So this is another antigen antibody reaction test that is called as agglutination. Definition or principle of this agglutination is same like precipitation, only one difference. I have already told that is the physical nature of antigen is different here. So what is the definition of agglutination? When particulate or insoluble antigen is mixed with its antibody in presence of electrolyte, that is sodium chloride, at suitable temperature and pH, there is formation of agglutination or clumping that we can see, that is called agglutination reaction. These are the examples of agglutination reaction: slide agglutination reaction, tube agglutination reaction. This tube agglutination reaction, example of this test is for diagnosis of typhoid fever. Viral test is done by this tube agglutination test. Then antiglobulin detection, that is home test, passive agglutination test, co-agglutination test. So these are the examples of agglutination test. So first we will see about the slide agglutination test. So this is an example you might have seen, that is blood grouping. If you have seen the procedure, that grouping and cross matching is that nothing but that is the example of slide agglutination test. Blood is fixed with the antigen. When a drop of appropriate antiserum is added on the slide, uniform suspension of particulate antigen is there in the saline. There is formation of agglutination. So this here we can see properly formation of small particles are there, that is agglutination. Examples are that slide agglutination is blood grouping and cross matching and identification of the bacterial isotope. Then another example of agglutination test is tube agglutination test. Agglutination is done in the test tube. This is example typhoid fever. Blood is tested by this test. Again, for diagnosis of brucellosis and typhus fever. So this is the method for estimation or titer we can detect it in this test. See here, you can see when fixed volume of particulate antigen is mixed with the equal volume of diluted serum in the test tube. So here you can see this is the titer, 1 by 20, this is doubling dilution, 120, 1 raised to 40, 1 raised to 60, no, 80, sorry, 40, 80, 160, 320 like this. To see here some antibodies are excess. You can see at this the antigen antibody is in equivalence. So this is the titer 160 here it is given. 1 raised to 160 dilution. That is called as titer of that test. Here antigen might be excess, so no agglutination we can see. So this is the diagnosis of typhoid, that is tube agglutination test, and titer of that test is also detected by this. This is passive agglutination test. This is basically converted test. Precipitation reaction is converted into agglutination reaction. That's why this reaction is called as passive agglutination reaction. So we have seen precipitation reaction is very sensitive for detection of antigen. For that purpose, this conversion is done. So when soluble antigen is coated on some inert particle, that particle might be red blood cells, polystyrene latex particle, bentonite, charcoal. So these are three small particles on that soluble antigen is coated. So it becomes insoluble. So passive agglutination test is conversion of precipitation reaction into agglutination reaction. There is reverse passive agglutination also when instead of antigen, antibody is coated on inner particle that becomes reverse passive agglutination reaction. You only remember about passive agglutination reaction that examples are very common tests we will see. So these are the examples of passive agglutination test. Rheumatoid factor, short RA factor. Clinically, you might have read about this test. C-reactive protein or CRP, that is increased serum protein in some diseases, or it is used for diagnosis of pneumonia or in any destruction of the tissues. This CRP get. So this is CRP test. Rheumatoid factor. That rheumatoid factor is autoimmune disease, arthritis. In that factor is detected. This is ASO anti-streptolysin test that is also commonly done in streptococcal infection or non-viral streptococci. You will see in that topic ASO anti-streptolysin test and pregnancy test. So these are the examples of passive agglutination test. You should know these are the examples and what is the principle of passive agglutination. Just now we have seen this is the conversion of soluble and precipitation reaction into agglutination. This is coagglutination reaction. We will see detail about in typhoid, fever, or typhoid, salmonella bacteria. Coagglutination, the combination of this staphylococcus. This is bacteria and staphylococcus on which antigen is coated. So the site is free for binding of the another antibody. That's why it is called as coagglutination test. Bloom's test. This is also a coagglutination test. Bloom test you might have seen in the uh, RH negative mother. That is RH positive and negative means mother is positive and fetus is negative. In that case, that test is done. Positive. Detection of test, detection of irritation, anti-RH antibody, and for detection of autoimmune hemolytic anemia. That test is complement fixation test. Uh, time it's okay. 5 to 10 complement fixation test. It is not very much important. Uses of this test is diagnosis of trypanosoma pallidum, cholera, brucella, Orienta, chlamydia, rickettsia. These are the bacteria. And some viral diseases are there also detected by CF2 test, parasitic infection, and some malaria. This is example of again neutralization test. Just see the names. Naegler's reaction. Naegler reaction. See in the Clostridium. They are not started bacteria, so it is difficult to understand. Just immunofluorescence test itself suggests that fluorescence rays, fluorescence dyes absorb UV light and convert it into visible lights. So we can see the fluorescence like this. Dengue virus is fluorescent like we can see. Principal will be examples: dengue virus, rabies, typhus, herpes virus, IgM can be detected by fluorescence. short, it is called as ELISA. It is enzyme immunoassay which is highly sensitive test. Diagram we will see what is the ELISA. This is the two types of ELISA are here: direct ELISA and indirect ELISA. See, antigen is coated on the weight. If you have seen the small slides are here, the washing, these are the various steps how it is done. Very different tests are there: indirect, and this one is sandwich ELISA. There are different type of ELISA: direct ELISA, indirect ELISA, and sandwich ELISA. Which is enzyme immuno-fluorescence testing. Application of ELISA for detection of HIV, it is very important. HIV-1 and HIV-2, HPSAG, that is hepatitis, antigen and antibody detection, chlamydia, antigen and antibody detection, cytomegalovirus, detection of antigen, rotavirus, rubella virus. Some thyroid hormone can be detected by ELISA. So these are the applications. This is ELISA machine you might have seen. These are the microtiter. Just now we have seen the slide. These are the waves. How it is done. These are the positive results. These are the waves on the slide. Micro slide is here. Right. And this is the ELISA reader. You might have seen it. This is a central laboratory. You can see. Western-blot. This is confirmation test. For that, some specialized laboratories should be there. It is not done in our laboratory. That sample should be sent to the further laboratory. That is confirmation test for HIV-1 and HIV-2 Western-blot test. Detection of okay, about the antibody reaction.